Hello everyone, my name is Samuel Esong and welcome back to my YouTube channel. In this video, we are going to look at Horizontal Pod Autoscaler, also known as HPA. So we are going to see why we need HPA. Then from there, we will move to a practical demonstration. So far, we have looked at deployment, we have looked at services, we've seen how service routes traffic, and we've also looked at ingress. But now, here's a very big question. What happens if your application suddenly gets more traffic than usual? Let's say your three-pod deployment might not handle the load and users experience slow responses or errors. Now, you cannot manually scale pods because this is going to be tedious and it's going to be reactive, all right? It is not that elastic. So this is where horizontal pod autoscheduler comes in. So HPA is going to automatically adjust the number of ports in a deployment, can your replica set or even a stateful set based on the observed metrics. All right. So these metrics can be CPU, all right, it can be memory, then it can even be your own custom metrics. So now let us look at how HPA works. So what happens is that HPA continuously watches metrics, all right, and compares them with the desired threshold. All right, so let's take for instance that your deployment has one replica and your CPU threshold is set to 50%. Now, what HPA will do is to monitor the CPU usage. If the average CPU usage is greater than 50%, then HPA will add ports. If it is less than 50%, HPA is going to remove ports. Now, for HPA to work, you need to have metric server installed. All right. So because HPA will need to do what? Scale automatically. No manual intervention is required. So HPA can work with deployments, it can work with replica sets, it can work with stateful sets. All right. So let us see how all of this adds up with a practical demonstration. But first, we must do what the very first prerequisite must or is to have a metric server installed. All right. If you are using a Minikube, I am using a Minikube cluster. So if I do Minikube get nodes, I should see my Minikube node ready. All right. So now, to confirm if you have the metric server installed, now metric server comes as an add-on in Minikube. So if I do Minikube add-ons list, so this is going to list the add-ons we have with Minikube. All right. So you can see that I have my metric server enabled. All right. So you can also enable yours. And to enable the metric server, you simply do Minikube add-ons enable, then the name of the add-ons you want to enable. In this case, we have the metrics server. So Minikube is going to add the metric server to your cluster. You can also manually install the metric server in your cluster. All right. So, and also before we go into the practical aspect, or okay, before then, to confirm, you can, because the metric server can or is found in the kube system namespace. So we are going to do kubectl get deployment. The name of the deployment is metrics server. -n kube system. So we can see that our metric server deployment is up and is also running. As usual, you can find a whole lot of this in the Kubernetes documentation. All right, so this is the horizontal pod auto scaling in the Kubernetes documentation. So you can take a look at this and read up. So this is how it works. You have the horizontal pod autoscaler here. All right, it is mapped to your deployment and it's going to scale the replicas based on the metric. So it can be CPU, it can also be based on memory. So you can take a look at this documentation and work around this algorithm. All right, and then there is a practical resource for you to check through. All right, so for us to experiment with HPA, we are going to create a deployment. All right, then we are going to create an HPA resource. So let us take a look at it. So I have a deployment here and I also have an HPA resource file here. All right, so let us take a look at our deployment. Nano, it is a very simple Nginx deployment. All right, so we are using one replica set. All right, and these are our selector, but we are more concerned with the spec or the containers.resources. So if you check the resources.request, we are simply saying that the request can the pod can request 100 milli CPU. So 100 milli CPU is just 10% of 1 CPU. All right. So 100 milli CPU is equivalent of 10% of 1 CPU. All right. So that means a pod can request 100 milli CPU. Then we also have a resource.limit. On the resource.limit, that means a pod can use up to 500 milli CPU. So this is what the 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 Kubernetes. This is what Kubernetes is going to use to create this pod. All right, to create this deployment. All right. So with the request, we have 100 milli CPU, but then if this pod is being created, this pod cannot use more than 500 milli CPU. So this is just with this. So Kubernetes only use these numbers to decide when to scale pod. All right. So let us apply this deployment. kubectl apply -f nginx HPA deployment. So our deployment has been created. Let us take a look at the HPA YAML file. So this is a declarative HPA resource. All right. For the first one is the API group that HPA belongs to. Now, this is a name our HPA is going to assume, and the spec is the most important section of this resource. Now, we have the scale target ref. So the scale target ref points to the deployment to scale. So this points to our deployment, and this is the name of our deployment. So to confirm, can simply do kubectl get deploy. So it points to this guy, and presently we have just one replica running. Now we have minimum replicas. So the minimum replicas is where we define the minimum pod to run. All right. So this minimum replica is going to override our current replica in our deployment. All right. Then the maximum replica is the maximum number of pods the HPA can scale to. Again, minimum replica is the minimum number of pod the HPA can scale to. All right. Now, under the metrics, we have the resource type. So this is going to scale based on CPU utilization. This is going to scale based on CPU utilization, all right? And the desired average CPU usage across all ports is 50, which is 50%. So what happens is that we have, in our deployment, we had 100 milli CPU as our request, all right? So the average utilization, which is 50, so HPA will try to keep average CPU around 50, which is 50% of our request. So HPA is going to try to keep average utilization around 50 milli CPU. So when CPU exceeds 50 milli CPU per pod, HPA is going to do what? HPA is going to scale up. So we will apply the HPA resource. So our horizontal pod autoscaler has been created. So I can do kubectl get HPA. So you can see that our HPA has been created. Now I told us that this is going to override the pod we had, or the number of replica sets we had in our deployment. So if I should edit this guy and keep it at 1, so the initial or the minimum number of pod is going to reduce to 1. So now what happens is that um okay, we've not applied it, so let me apply this guy. All right, so we have reconfigured this. So if I do kubectl get HPA, we can see minimum number of pod has reduced from 2 to 1. All right, so let us try to simulate our to see how HPA reacts when we try to increase CPU usage. All right, so let us keep our HPA in the watch mode. So kubectl get HPA -w. All right, so what I'm going to do now is to use another terminal. So I'm going to exec into one of our ports. So if I do kubectl, already I will have just one port running, and because of kubectl get ports. All right, so I'm going to exec into one of these ports. So if I do kubectl exec -it, the name of the port, then -. All right, so I am going to do a very simple loop. All right, so I'm going to do a very simple loop. So it's going to be an infinite loop. So it's going to run forever doing nothing. So the main aim is to try to increase the CPU usage on this pod. All right. All right. Okay. So I'll type while true, do nothing, then done. Um, sorry guys. While true, okay, do nothing, done. All right, so this is going to increase our CPU usage in the pod we just exec into. All right, so we'll give it some time. All right, so you can see that the our CPU usage for the particular pod we exec into has increased from 0 to almost 72%. All right. So what actually happens in HPA is that HPA has a built-in stabilization window to avoid flapping. That is rapid up and down scaling. All right. So if you check, our replica set has increased from 2 to 3, and the maximum pod we defined in our HPA is 5. So when it gets to 5, then our replica set or our HPA will definitely do nothing because it cannot do anything more than 5. All right. So now I'm going to stop this operation and we are going to see how HPA is going to scale down. All right. So we have our maximum port at 5. All right. So we have our maximum port. Oh, yes. Our current replica is running at 5. All right. So if I break this, HPA is going to take a little time. It's going to wait for a few minutes, I think up to 5 minutes before reducing replica. So even though your CPU drops, even if your CPU is now below the target, because right now we have stopped the infinite loop. All right. So HPA is going to take some time. So if you check, our CPU is dropping. So let us see our CPU dropped below 50. Then we can see our HPA in action. Again, before you can achieve this, let me reemphasize that you must have your metric server installed, or you must enable your metric server. All right. So we have seen how our ports increased from 1 to 5. And we've also seen how CPU usage, when we stopped the infinite loop, we've seen how the CPU usage is decreasing. So right now, our CPU usage is at 0%. All right. And of course, I've already explained that because of the inbuilt stabilization mechanism that Kubernetes has in place, our CPU usage is going to take a little time, I think like 3 to 5 minutes for us to see reduction. So this is to prevent flapping. All right. So in essence, HPA is going to monitor our average CPU, which was our CPU utilization we set to 50%. And we've seen that scaling is gradual. It is not instant. Scaling is gradual to avoid trashing. So cooldown period in HPA prevent constant scaling. So HPA works on CPU, it works on memory, it also works with custom metrics. All right. So if you have stayed with me up to this point, you can also try to deploy an HPA with CPU request and limit. Create an HPA resource, all right? Then generate a CPU load, just like I have done with a loop. So you can experiment with different thresholds and maximum replicas and see what happens. Because the main aim is for you to understand how Kubernetes adapts to workload changes automatically, which is key for high availability and, of course, production grade applications. So thank you for staying with me um, until the end of this video. So please, if you are yet to subscribe to my channel, do well to subscribe to my channel, and you can share this video with your friends. And if you have any questions, you can send them in the comment section. So I'm going to reply to each and every one of them. So once again, thank you very much, and I'll see you in the next video. Thank you.